So let us start. The images, text and other materials used in our presentations are for educational purposes only. We respect the intellectual property rights of the original creators and owners. If you are the owner and have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the content immediately. Please note that parts of the content may have been generated using generative AI, which is experimental. So let us start now. So we will study NCERT Exercise 3.2. So question is, find the values of other 5 trigonometric functions. If cos x equal to minus 1 by 2, x lies in the third quadrant, right? We have to find the values of other 5 trigonometric functions if cos x equal to minus 1 by 2 and x lies in the third quadrant, right? Now we know that like in the third quadrant, cos x is negative, sin x is also negative, right? Similarly, you can say about all the other trigonometric functions, right? So in this way, you can easily find, see, cos x is equal to minus 1 by 2 is given, right? So we can find sin x by using 1 minus cos x is equal to 1 minus by using like sin x equal to 1 minus cos square x, right? Sin square x is equal to 1 minus cos square x, right? So we can easily find sin x, okay? So after finding sin x, we can find tan x, cot x, cosec x and sec x, right? So in this way, we can easily find like values of different trigonometric functions, okay? Okay, you have some time to solve or think about this question. After that, we will move to the solution part, right? Okay, hope you have attempted the question. Let's move to the solution part. Let's move to the solution part. Question is, find the values of other 5 trigonometric functions if cos x equal to minus 1 by 2, x lies in the third quadrant, right? We have to find the values of other 5 trigonometric functions if cos x equal to minus 1 by 2 and x lies in the third quadrant, right? So answer is sin x will be equal to minus root 3 by 2, cosec x will be equal to minus 2 by root 3, right? Sec x will be equal to minus 2, tan x will be root 3 and cot x will be 1 by root 3, right? Okay. So let us see the solution part. Given cos x equal to minus 1 by 2 and x lies in the third quadrant, right? Now since cos x equal to minus 1 by 2 and we know that sec x is basically equal to 1 upon cos x, right? Sec x is equal to 1 upon cos x, right? So this implies sec x will be equal to 1 upon minus 1 by 2, right? Sec x will be equal to 1 upon minus 1 by 2. Therefore, sec x will be equal to minus 2, right? Sec x will be equal to minus 2, okay? Right? So we got sec x equal to minus 2. Now using Pythagorean identity, we know that sin square x plus cos square x is equal to 1, right? Sin square x plus cos square x is equal to 1. So we can write like sin square x equal to 1 minus cos square x, right? Sin square x will be equal to 1 minus cos square x. Therefore, sin square x will be equal to 1 minus 1 by 2 whole square, which is equal to 1 minus 1 by 4, right, which is equal to 3 by 4. Okay, therefore we can write sin x will be equal to plus minus root 3 by 2, right? Sin x will be equal to plus minus root 3 by 2. Okay, since x lies in the third quadrant, the value of sin x will be negative, right? Since x lies in the third quadrant, so the value of sin x will be negative. Okay, therefore sin x will be equal to minus root 3 by 2, right? Hence we can say that the value of sin x will be equal to minus root 3 by 2. Okay, right? Now using the identity cosec x is equal to 1 upon sin x. We know that cosec x is basically equal to 1 upon sin x, so we get cosec x will be equal to 1 upon minus root 3 by 2, right? Cosec x will be equal to 1 upon minus root 3 by 2, which is equal to minus 2 upon root 3, right? Which is equal to minus 2 upon root 3. Since we know that tan x equal to sin x upon cos x, so tan x will be equal to minus root 3 by 2 upon minus 1 by 2, right? Which is equal to root 3. Hence we can say that tan x equal to root 3, right? Now cot x equal to 1 upon tan x. Therefore cot x will be 1 upon root 3. Since tan x is root 3, so cot x is since basically equal to 1 upon root 3. 1 upon tan x, so cot x will be equal to 1 upon root 3. Okay. Hence we have like found all the trigonometric ratios. Okay. Right. We have got like cos x is given minus 1 by 2. We have got now sin x, cos sin x, tan x, cot x, sec x, and cosec x. Okay. Okay. Hope you all have understood this. Let us move to the next question. Question number 2. Find the values of other 5 trigonometric functions if sin x is equal to 3 by 5 and x lies in the second quadrant, right? Sin x is given as 3 by 5 and x lies in the second quadrant, right? We have to find other trigonometric functions. Okay. Again, see, sin x is equal to 3 by 5 and x is lying second quadrant, and we know that in second quadrant sin x is positive, cos x is negative, right? Clear? So similarly, we can talk about all the other trigonometric functions in the second quadrant, right? And we can easily find the value of all the trigonometric functions. Clear? And we know that like sin square x plus cos square x equal to 1. So using this identity, we can find like find the value of cos x, and after that we can easily find tan x, sec x, cosec x, and cot x, right? So in this way, you can try to attempt this question. We have some times to solve or think about this question. After that, we will move to the solution part, right? Okay, so we can now we can find other 5 trigonometric functions, right? You all can try to attempt. After that, I'll solve this. Okay, hope you all have attempted this. Let's move to the solution part now. We have to find the values of other 5 trigonometric functions if sin x equal to 3 by 5 and x lies in the second quadrant, right? X is lying in the second quadrant, and we need to find the other 5 trigonometric functions. Sin x is already given. We need to find cos x, tan x, cot x, cosec x, and sec x, right? So the correct answer will be cosec x is equal to 5 by 3, cos x is equal to minus 4 by 3, sec x is equal to minus 5 by 4, tan x equal to minus 3 by 4, and cot x will be equal to minus 4 upon 3. Okay. So given that sin x equal to 3 by 5, right? It is given that sin x is equal to 3 by 5 and x lies in the second quadrant, right? It is given that sin x is equal to 3 by 5 and x lies in the second quadrant. Okay. Since we know that cosec x is equal to 1 upon sin x, right? Since we know that cosec x is equal to 1 upon sin x. Now sin x equal to 3 by 5, therefore cosec x will be 1 upon 3 by 5, right? So cosec x equal to 1 upon sin x. So cosec x will be 1 upon 3 by 5, okay? Therefore, we can say that cosec x will be 5 upon 3, right? Cosec x will be 5 upon 3, right? Right, sin x, so sin x was 3 by 5, so cosec x is now 5 upon 3, right? Okay, hope you understood till here. Now using Pythagorean identity, we know that sin square x plus cos square x is equal to 1, right? We know that sin square x plus cos square x is equal to 1, okay? So cos square x will be equal to 1 minus sin square x, since sin square x plus cos square x is equal to 1. So we can easily find cos square x, which will be equal to 1 minus sin square x, right? Now cos square x can be written as equal to 1 minus, since we have already calculated or it is given in the question sin x equal to 3 by 5 x, 3 by 5. So cos square x will be 1 minus 3 by 5 whole square, which is equal to 1 minus 9 upon 25, right? So cos square x will be equal to 1 minus 9 upon 25, which is equal to 16 upon 25, right? So cos square x will be equal to 16 upon 25, right? So cos square x will be equal to 16 upon 25. So since cos square x is equal to 16 upon 25, so cos x will be equal to plus minus 4 by 5, right? Cos x will be plus minus 4 by 5. Now x lies in the second quadrant. Since x lies in the second quadrant, the value of x will be negative, right? As we know that value of cos x will be negative, as we know that cos x is basically negative in the second quadrant, right? Therefore cos x is basically equal to minus 4 upon 5, clear? Hence we can say that cos x equal to minus 4 upon 5, right? So cos x will be equal to minus 4 upon 5. Hope you all have understood this. Okay. Now using the identity sec x equal to 1 upon cos x, we know that sec x is equal to 1 upon cos x, therefore we get sec x is equal to 1 upon minus 4 by 5, because we have already calculated we have already calculated cos x. So sec x will be equal to 1 upon minus 4 by 5, which is equal to minus 5 by 4, right? So sec x will be equal to minus 5 by 4. Okay. Now, since tan x is equal to sin x upon cos x, since we have already calculated sin x and cos x, right? Sin x is given in the question as 3 by 5, right? So we can we have already calculated cos x. So tan x will be sin x upon cos x. Therefore, tan x will be equal to 3 by 5 upon minus 4 by 5, right? So tan x will be equal to 3 by 5 upon minus 4 by 5, which is equal to minus 3 by 4. Clear? Which is equal to minus 3 by 4. Now, like cot x is basically 1 upon tan x, right? Cot x is basically 1 upon tan x. Therefore, cot x will be equal to minus 4 upon 3, right? Therefore, cot x will be equal to minus 4 upon 3, right? Clear? So now we have already calculated all the trigonometric ratios, right? We have calculated cos x, cosec x, sec x, tan x and cot x. Clear? Hope you all have understood this. Okay. Let's move to the next question, which is find the values of other 5 trigonometric functions if cot x equal to 3 by 5, x lies in the third quadrant, right? We have to find the values of other 5 trigonometric functions if cot x equal to 3 by 5 and x lies in the third quadrant, right? So how can we attempt this? Cot x is given as 3 by 4, right? And x is lying in the third quadrant. Now we know that in the third quadrant, cot x is positive, sin x is negative and cos x is negative, right? Sin x is negative and cos x is negative, okay? So in the we can easily calculate other trigonometric functions by using cot x equal to 3 by 4, right? Now again you have some time to solve or think about this question. After that we will move to a solution part, right? Okay, hope you all have attempted. Let's move to the solution part. We have to find the values of other 5 trigonometric functions. If cot x equal to 3 by 4, x lies in the third quadrant. Then we have to find basically other 5 trigonometric functions, okay? Now, correct answer is sin x is minus 4 by 5, cosec x is minus 5 by 4, cos x is minus 3 by 5, sec x is minus 5 by 3, and tan x is 4 upon 3, right? Now, let us try to calculate this. It is given that cot x equal to 3 by 4 and x lies in the third quadrant, right? It is given that cot x equal to 3 by 4 and x lies in the third quadrant. Since tan x equal to 1 upon cot x, Now since tan x equal to 1 upon cot x, so therefore we can write tan x equal to 1 upon 3 by 4, right? Tan x will be equal to 1 upon 3 by 4, which is equal to 4 upon 3, right? Therefore tan x will be equal to 4 upon 3, right? Therefore tan x will be equal to 4 upon 3. Clear? So tan x will be equal to 4 upon 3, right? Now using Pythagorean identity, which is like 1 plus tan square x equal to sec square x. 1 plus tan square x is basically equal to sec square x, right? Therefore, sec square x will be 1 plus 4 by 3 whole square, right? Sec square x will be equal to 1 plus 4 by 3 whole square, which is equal to 1 plus 16 upon 9, right? Which is equal to 1 plus 16 upon 9, which is equal to 25 upon 9, right? This implies sec x is basically equal to plus minus 5 upon 3, right? So we can say that sec x is equal to plus minus 5 upon 3. Since x lies in the third quadrant, the value of sec x will be negative, right? Since x lies in the third quadrant, the value of sec x will be negative. Therefore, we can say that sec x is basically equal to minus 5 upon 3, right? Sec x is equal to minus 5 upon 3, right? Now, using the identity cos x is equal to 1 upon sec x, using the identity cos x is equal to 1 upon sec x, we get cos x will be equal to 1 upon minus 5 by 3, right? Cos x will be equal to 1 upon minus 5 by 3, which is equal to minus 3 upon 5. Now, using the identity, which is tan x equal to sin x upon cos x, we know that tan x equal to sin upon cos x, sin x upon cos x. So, sin x will be basically tan x into cos x, right? Sin x will be tan x into cos x. Therefore, we can write sin x is equal to 4 upon 3 into minus 3 upon 5, right? Sin x is equal to 4 upon 3 into minus 3 upon 5, which is equal to minus 4 upon 5, okay? Now, cosec x is equal to 1 upon sin x. Cosec x is basically equal to 1 upon sin x. Therefore, we can say that cosec x will be equal to minus 5 upon 4, right? We can say that cosec x will be equal to minus 5 upon 4, okay? Okay, let's move to the next question. NCERT exercise 3.2, question number 4. This question says, find the values of other 5 trigonometric functions if sec x is equal to 13 by 5, x lies in the fourth quadrant. Sec x is equal to 13 by 5 and x lies in the fourth quadrant. Now, since x lies in the fourth quadrant, we can say that like cos x will be positive, sin x will be negative, right? Cos x will be positive, sin x will be negative, and sec x is given, and we can easily find other trigonometric functions by using some identity, okay? So in this way, you can try to attempt this question. You have some time to solve or think about this question. After that, we will move to the solution part, right? Okay, let's move to the solution part. Question is, find the values of other 5 trigonometric functions if sec x equal to 13 by 5, x lies in the fourth quadrant, right? So correct answer will be sin x equal to minus 12 by 13, cosec x is equal to minus 13 by 12, cos x is equal to 5 by 13, tan x equal to minus 12 by 5, and cot x equal to minus 5 by 12, right? Now it is given that sec x equal to 13 by 5 and x lies in the fourth quadrant, right? Given that sec x equal to 13 by 5 and x lies in the fourth quadrant, okay? Using the identity cos x equal to 1 upon sec x, right? Using the identity cos x equal to 1 upon sec x, clear? So cos x will be equal to 1 upon 13 by 5, right? Cos x will be equal to 1 upon 13 by 5, which is equal to 5 upon 13, right? Therefore, cos x will be equal to 5 upon 13, right? Cos x will be equal to 5 upon 13, okay? Now using Pythagorean identity, which is sin square x plus cos square x equal to 1, we can say that sin square x will be equal to 1 minus cos square x, right? So sin square x will be equal to 1 minus 5 by 13 whole square, right? Sin square x will be equal to 1 minus 5 by 13 whole square, which is equal to 1 minus 25 upon 169, right? Which will be equal to 144 upon 169, right? So sin square x will be equal to 144 upon 169. So sin x will be equal to plus minus 12 upon 13, right? Sin x will be equal to plus minus 12 upon 13. Since x lies in the fourth quadrant, the value of sin x will be negative. Since x lies in the fourth quadrant, the value of sin x will be negative, right? Therefore, sin x will be equal to minus 12 upon 13. Therefore, we can say that sin x will be equal to minus 12 upon 13. Okay. Now, using the identity cosec x equal to 1 upon sin x, we get, using the identity cosec x equal to 1 upon sin x, we get cosec x will be equal to 1 upon minus 12 upon 13, right? Cosec x will be equal to 1 upon minus 12 by 13, which is equal to minus 13 upon 12, right? Which is equal to minus 13 upon 12. Now, since tan x equal to sin x upon cos x, since tan x equal to sin x upon cos x, therefore, tan x will be equal to minus 12 upon 13 upon 5 upon 13, right? Therefore, tan x will be equal to minus 12 upon 13 upon 5 upon 13. After further simplification, we can get tan x equal to minus 12 upon 5, right? Tan x will be equal to minus 12 upon 5, as 13 and 13 will cancel out, okay? Now, cot x will be equal to 1 upon tan x. Cot x will be equal to 1 upon tan x. Therefore, cot x will be equal to 1 upon minus 12 by 5, right? Cot x will be equal to 1 upon minus 12 by 5, which is equal to minus 5 upon 12, right? Cot x will be equal to minus 5 upon 12, right? Okay, so let us move to the next question now. Find the NCERT Exercise 3.2, question number 5, which says find the values of other trigonometric functions if tan x equal to minus 5 by 12, where x lies in the second quadrant, right? We are given that tan x equal to minus 5 by 12 and x lies in the second quadrant, okay? See, tan x is given as minus 5 by 12, and when x lies in the second quadrant, we can say that in the second quadrant, tan x is negative, sin x will be positive, and cos x will be negative, right? Clear? Similarly, we can say about other trigonometric functions also, right? And from tan x, we can easily find sec x by using trigonometric identities, and after that, we can easily find sin x, cos x, cosec x, and and cot x, right? So in this way, you can try to attempt this question. You have some time to solve or think about this question. After that, we will move to a solution part, right? Okay, let us see the solution part. Find the values of other 5 trigonometric functions if tan x equal to minus 5 by 12, where x lies in the second quadrant. Okay. So correct answer is sin x is equal to 5 by 13, cosec x is equal to 13 by 5, cos x will be equal to minus 12 by 13, sec x is equal to minus 13 by 12, cot x is equal to minus 12 by 5, right? Now let us see. It is given that tan x equal to minus 5 by 12, right? It is given that tan x equal to minus 5 by 12 and x lies in the second quadrant. Since cot x equal to 1 upon tan x, cot x equal to 1 upon tan x, therefore cot x will be equal to 1 upon minus 5 upon 12, right? Therefore cot x will be equal to 1 upon minus 5 by 12, which is equal to minus 12 by 5. Therefore we can say that cot x will be equal to minus 12 by 5, right? We can say that cot x will be equal to minus 12 by 5. Okay. Now using Pythagorean identity, which is 1 plus tan square x equal to sec square x, we can find sec square x will be 1 plus minus 5 by 12 whole square. Okay. So it can be written as 1 plus 25 upon 144, which is basically 169 upon 144, right? So sec x will be equal to plus minus 13 upon 12, right? Sec x will be equal to plus minus 13 upon 12. Since x lies in the second quadrant, the value of sec x will be negative, right? Since x lies in the second quadrant, the value of sec x will be negative. Okay. Therefore, sec x will be equal to minus 13 upon 12. Clear? We can easily say sec x will be equal to minus 13 upon 12. Using the identity cos x equal to 1 upon sec x, we get, using the identity cos x equal to 1 upon sec x, we get cos x equal to 1 upon minus 3 by 12 is equal to minus 12 by 3, minus 13 upon 12, which is equal to minus 12 upon 13. Since tan x equal to sin x upon cos x, since tan x equal to sin x upon cos x, therefore sin x will be equal to tan x into cos x, right? Sin x will be equal to tan x into cos x, which is equal to minus 5 by 12 into minus 12 by 13, right? Which is equal to 5 upon 13, right? Which is equal to 5 upon 13. Okay. Now cosec x is equal to 1 upon sin x. We know that cosec x is equal to 1 upon sin x. So cosec x will be equal to 1 upon 5 upon 13, which is equal to 13 upon 5. Clear? Which is equal to 13 upon 5, right? Okay. Hope you all have understood. Let us move to the next question. NCERT Exercise 3.2, question number 6, which says find the values of the trigonometric function sine 765 degree. We need to find the value of the trigonometric function sine 765 degree, right? Okay. Okay, again you have some time to solve or think about this question. After that we will move to the solution part, right? So we need to find the value of trigonometric functions sine 765 degree, right? Sine 765 degree, okay? So correct answer will be 1 by root 2. Let us see the solution part. It is known that the value of sin x repeats after the interval of 2 pi or 360 degree. We know that the value of sin x repeat after an interval of 2 pi or 360 degree. Therefore, sin 765 degree will be, we can be written as sin 2 into 365, 2 into 360 degree plus 45 degree, right? It can be written as sin 2 into 360 degree into 45 degree. which is equal to sine 45 degree, right? Which is equal to sine 45 degree, right? Which is equal to 1 upon root 2, right? Hence we can say that sine 765 degree will be equal to 1 upon root 2, okay? And we know that sine 2 pi plus theta is basically equal to sine theta. Therefore, sine 2 into 360 degree plus 45 degree is basically equal to sine 45 degree, okay? Which is equal to 1 upon root 2, okay? Okay, let us move to the next question. Okay, hence like therefore sine 765 degree will be equal to 1 upon root 2, okay? Question number 7, NCERT exercise 3.2, question number 7. Find the value of trigonometric function cosec minus 1410 degree, right? We have to basically find the value of trigonometric function cosec minus 1410 degree, right? So how can we find? Again, we know that sine 2 pi plus theta will be basically equal to sine theta, right? Or then cosec 2 pi plus theta will again equal to cosec theta, okay? So again, you have some time to solve or think about this question. After that, we will move to a solution part, right? Okay. So we have to find the value of trigonometric functions, right? Cosec minus 1410 degree, right? So correct answer will be 2. Clear? Now it is known that the values of cosec x repeats after an interval of 2 pi or 360 degree, right? It is known that the values of cosec x repeats after an interval of 2 pi or 360 degree. Therefore, cosec minus 1410 degree is basically equal to cosec minus 1410 degree plus 4 into 360 degree, right? So cosec minus 1410 degree is basically equal to cosec minus 1410 degree plus 4 into 360 degree, okay? Which is equal to cosec minus 1410 degree plus 1440 degree. Clear? Which is equal to cosec 30 degree. Clear? Which is equal to cosec 30 degree. Right? Which is equal to 2. Therefore, cosec minus 1410 degree is equal to 2. Okay? We can say that cosec minus 1410 degree is equal to 2. Right? Okay. Hence, like we can say that cosec minus 1410 degree is basically 2, right? Now, NCERT exercise 3.2, question number 8. Right? Find the value of trigonometric function tan 19 pi by 3. We have to find basically the trigonometric function of, we have to find trigonometric function, the value of trigonometric function tan 19 pi by 3. Okay. So how can we find? Again, we can try to convert tan 19 pi upon 3 in terms of tan 2 pi plus theta or like 2 pi minus theta or some things like that, right? Okay. So in this way, you can try to attempt this question. You have some time to solve or think about this question. After that, we will move to the solution part, right? Okay, let us see the solution part. find the value of trigonometric function. We have to find the value of trigonometric function 10, 19 pi by 3, right? So correct answer will be root 3, right? Correct answer will be root 3. It is known that the values of 10x repeat after an interval of pi or 180 degree, right? We know that the values of 10x repeat after an interval of pi or 180 degree. Therefore, like 10, 19 pi upon 3 can be written as 10, 6 mixed 1 upon 3 pi, right? 6 mixed 1 upon 3 pi, which is equal to 10, 6 pi plus pi by 3, right? So 10, 19 pi upon 3 can be written as 10, 6 pi plus pi by 3, okay? Now we know that 10, 6 pi plus pi by 3 will be equal to 10 of pi by 3, right? 10, 6 pi plus pi by 3 will be equal to 10 of pi by 3. Now we know that 10 of pi by 3 is basically 10 of 60 degree, which is equal to root 3, okay? So correct answer will be root 3, okay? Correct answer will be root 3, right? Okay. So NCERT exercise 3.2 question number 9. Find the value of trigonometric function sine of minus 11 pi by 3. We have to find the value of trigonometric function sine of minus 11 pi by 3, right? Again, you have some time to solve or think about this question. After that, we'll move to a solution part, right? Okay, let us move to the solution part. Correct answer is root 3 by 2. It is known that the values of sine x repeats after an interval of 2 pi or 360 degree. Therefore, sine of minus 11 pi by 3 will be basically equal to sine of minus 11 pi by 3 plus 2 into 2 pi, right? Therefore, which is equal to sine of pi by 3. Clear? And we know that sine of pi by 3 is basically equal to root 3 by 2. Clear? So sine of minus 11 pi by 3 we have written as, because sine of 2 pi plus theta is equal to sine theta, right? So we have written as it as sine minus 11 pi by 3 plus 2 into 2 pi, which is further sine of pi by 3, which is equal to root 3 by 2, okay? Right? Okay. So let's move to the next question. NCERT exercise 3.2 question number 10. Find the value of trigonometric function cot of minus 15 pi by 4. We have to find the value of trigonometric function cot of minus 15 pi by 4, okay? So again, you have some time to solve or think about this question. After that, we'll move to the solution part, right? Okay, let's move to the solution part. Find the value of trigonometric function cot of minus 15 pi by 3, right? So correct answer will be 1. It is known that the values of cot x repeats after an interval of pi or 180 degree, right? Therefore, cot of minus 15 pi upon 4, cot of minus 15 pi upon 4 will be equal to cot of minus 15 pi upon 4 plus 4 pi, right? Which is equal to cot of 4 pi, cot of pi by 4, right? Which is equal to 1. Clear? Cot of 4 pi by 4, which is equal to 1, right? So correct answer will be 1, okay? Okay. Thank you so much.